Welcome back to the discussion and thank you for always joining us. We are presenting a question that was done in KCSE 2002 paper 1 question number 18, and the question we have reads, the figure below represents a right prism whose triangular faces are isosceles. The base and the height of the triangular face are 12 and 8 centimeters respectively. That means the height at this point is going to be 8 centimeters. The length of the prism is 20 centimeters. Calculate the length CE. For us to get the length CE, we are first going to get the length AC. And for us to get AC, we are going to use the height, which is 8, and also assuming this point here is N, then NC is going to be 6, and therefore using the right angle triangle NAC, then we are going to have AC as the square root of 8 squared plus 6 squared, giving us the square root of 100, and the square root of 100 is going to be 10 centimeters. Once we have done that, we can now get since we have gotten AC as 10 centimeters, remember ACDE is a rectangle with the vertices 90 degrees, and therefore now if we connect C to E, we are going to have a right angle triangle AEC, where CE is the hypotenuse, and therefore now to get CE, we are going to have the square root of the height squared, which is 10, plus 20 squared, and this one is going to give us a total of 500, since 10 squared is 100 and 20 squared is 400, and the square root of 500 is exactly approximately 22.36 centimeters. That is correct to 4 significant figures or 2 decimal places. Once we are done with part A of the question, we move to B, and in B we are supposed to calculate the angle between the line CE and the plane ABCD. Remember, when we talk about EBC and the plane ABCD, we are going to look at the common line of intersection of the line, or simply the projection of the line CE on the plane BCD, and therefore if you bring down the projection of EC on the plane BCDF, then the point of intersection between the two is going to be from C moving towards this particular point at the center of that particular line, and then we drop a perpendicular from E to meet the line of projection of the line CE, then we are going to have a point O at that particular point. That means now we can extract this triangle like this, where we are going to have the angle theta that is required at this point. We can place the angle theta here because that is the angle between the projection of CE on the plane and the line itself. So this is a point C, this is a point O, and this is E here. Already CE has been found to be 22.36, and also the height of this particular triangle from O to E is the same as A to N, and this one is going to be 8 centimeters. From there now we can get the angle. Since we have OE as 8 centimeters, according to the angle we have the opposite and the hypotenuse, we are going to use the sine theta, which is given by opposite. Opposite is 8 over, hypotenuse is 22.36, and that one is going to be equal to the angle theta being the sine inverse of 8 over 22.36, and this one is going to translate to an angle equivalent to 20.97 degrees, correct to 4 significant figures. After that, we move to Roman 2 of the same question, and in Roman 2, we need the angle between the plane EBC. So EBC is the angle, is the triangle that we are going to join from E then to B to C, and therefore look at the base, which is B, C, D, E, F. So I'm going to draw the two planes, and the two planes are going to look like this. That is the first plane we have here, and the plane is B, C, D, then this is F here. And now we are going to, we now draw the plane EBC. Already we have BC, so we need to locate the point E at this point, and of course join it to this point here. So we need the angle between BEC and BCDF. So we look at the common intersection, and for us to get the common intersection, we are going to draw a line from E all the way to the common line of intersection of the two, which is B. Then draw another line from BC towards the center of CF. The angle we need is going to be the angle theta here. So if I join a line from E to the common point of intersection at this point, we can call this particular point a point O, or simply M. Then use this triangle here. We use this triangle to get the angle in question. This is the angle theta here. We can join or drop a perpendicular to meet this at point M. Let me call this point N here, and of course this is a point E. From here we know that NM is the length, and the length of this is 20 centimeters. And of course ME is the height, which is 8 centimeters. With the two sides, we are able to get the angle by using the tangent. Tan theta is given by opposite, which is 8 over the adjacent, which is 20. And for us to get the angle theta, we are going to find the tan inverse of 8 over 20. And this one is going to give us an answer equivalent to 21.80 degrees, correct to 4 significant figures, or simply 2 decimal places. Thank you for watching and welcome to our discussions. And in case you are watching this channel for the first time, please take a second or two, click the subscribe button so that anytime we publish a video like this, you will automatically be given a notification. Thank you and welcome.